Hello, this is the lesson for section 5.6, the remainder and factor theorem. And then we're going to do this in a couple parts. I'm going to do the best I can to try to explain what the remainder theorem is and how we're going to deal with it. Please read the book. You should be able to follow along there as well. And they'll do it maybe a little bit differently than I am, and watch the videos, the tutorials on section 5.6, and that will help you as well. But this is probably one of the hardest, not hardest, probably the most important concepts that you will need through chapter 5, the rest of chapter 5, and then we'll be dealing with these concepts for the rest of the book. So you definitely want to understand section 5.6. Okay, so the 5.6 is on the remainder and the factor theorems. Now, the first goal is called synthetic substitution, and I'm going to get into why it's called that instead of synthetic division like we did earlier. So, for example, here's what we're doing. We take any polynomial, f of x, okay? So I just made one up. 2x cubed minus 4x squared plus 5x plus 6. And if we wanted to evaluate f of 2, okay, we would normally use what we call direct substitution to do that. So we would use direct substitution by evaluating f of 2 by plugging in 2 in for all of the x's in the function. We plug them in directly. That's why it's called direct substitution. And then we use the order of operations to evaluate. So 2 cubed is 8, 8 times 2 is 16, 2 squared is 4, 4 times 4 is 16, plus 10 plus 6. So basically 16 minus 16 is 0 plus 16, so my evaluated answer is 16. So f of 2 equals 16. Now, let's say instead of evaluating 2, we want to divide by x minus 2. Okay, so we're going to go ahead and do that. Let's divide this polynomial by this using synthetic division. Okay, so if I do that, I put in positive 2 here. I put in the coefficients 2, negative 4, 5, and 6, and I go ahead and evaluate. If I evaluate f of x and divide by x minus 2, this is how I'm going to do it. So I drop the 2, multiply, 0, multiply, add, I get 16. The remainder, when you divide by x minus 2, is 16. When you evaluate f of 2, it's also 16. That is the remainder theorem in a nutshell. That you can divide by x minus 2 or use what we call synthetic substitution to evaluate 2 rather than direct substitution. Okay, so let's talk just a little bit more in depth of the details. I'm going to focus you right over here. There's a glare, so I'm going to move this. Doesn't take but a second. Okay, the remainder theorem basically says this, and this is in the book, and this is why I'm bringing it up. You don't necessarily need to know the exact ins and outs of this, but a lot of you like to know why and so on. So basically what I'm doing is I'm just talking about what I just did over here on my left, and the p of x, we'll call it the polynomial I just evaluated, is equal to, and this answer, if you look here using synthetic division, is 2x squared plus 5. So this is 2x squared plus 5 times what we divided by, x minus 2, plus the remainder. So that's basically what this polynomial is. If I multiplied these two together and then added 16, I would get what I started with. And that's what when you divide, that's what you're basically ending with. If I divided both sides by x minus 2, of course you have to divide everything, you end up with what I did when I divided this by x minus 2, I ended up with the 2x squared plus 5, right here, 2x squared plus 5, plus the 16 over the x minus 2. This is what we did when we were doing long and synthetic division. This is basically what they're telling you the remainder theorem is. And all they're basically saying is the remainder is the same as what the when you evaluate. So, with that said, let's just use synthetic substitution. If I wanted to evaluate f of negative 5 instead, I wouldn't necessarily plug it in directly like I did over on this side. I could also use synthetic substitution. So I would put negative 5 into the box. I would put the coefficients of the terms in here, just like we did, and I would evaluate. Okay, so I dropped the 2, negative 10, negative 14, multiply, that would be 70, 75, multiply, negative, let's see, 75 times 5 is 375, so negative 375, which gives me negative 369. So to evaluate negative 5, I could use synthetic substitution instead, so my answer is negative 369. There I am, using this. Now, it's the same thing as synthetic division. You're just using substitution to find out what it equals. Okay?